form. So we have our setup of the apparatus. So the apparatus is set up as above. We should label our apparatus now. So we have our solid lead to bromide inside. This is a crossbar made of silica. Then we have a tripod stand, have our ammeter, have the battery, have the anode, the positive terminal, then we have the cathode, the negative terminal. So that is our setup. Then we have more solid lead to bromide crystals. In this sense, we are going to use carbon electrodes. When the carbon electrodes are dipped into the solid lead to bromide crystals and the circuit is completed, the ammeter did not deflect. Why? Because there was no conduction of electric current. This is because that the ions that are responsible for the conduction of electricity were locked up in a solid crystal, so they are not free to move from one point to the other, so there is no conduction. That's why at the beginning this ammeter does not deflect. What do we do to make the ammeter deflect? We bring a Bunsen burner down here. So we have our Bunsen burner. The Bunsen burner will hit the solid lead to bromide crystals, and at the end they will start melting. Of course, we shall have now liquid lead to bromide like that. So that means that the ions have been freed up, and at the end we are going to see the ammeter deflecting. Why? Because the electric circuit has been completed and now there is conduction of electric current. Therefore, the ammeter will deflect. On introduction of a Bunsen burner, if the lead to bromide is subjected to very high temperature, the crystals will melt, hence forming the ions responsible for the conduction of electric current. What do we have in solution? So the ions present, we have lead to bromide solids. This time, because it has melted, now we have the ions, so it is aqueous now. It gives us the lead to ions, aqueous, plus the bromide ions, aqueous. Put here 2 to balance the equation. This time around we don't have the water molecules because it's only lead to bromide that has been melted. It has not been dissolved in water. So we have lead in solution, lead to ions. We have lead to ions in solution. So the lead to ions will migrate to the cathode. They will migrate to the cathode, where they will get electrons, or they receive electrons from the cathode, hence becoming ordinary atoms, and will be discharged as silver gray solids. So at the cathode, we have lead to bromide. Cathode we have lead to ions getting electrons from the cathode and forming lead, a solid. So I put here 2 to balance the equation. Solid. So this one is a silvery gray solid. The silver gray solid. Then what happens at the anode? Again at the anode, we have the bromide ions in solution, of course randomly distributed bromide ions, which will migrate to the anode. Being that they are negatively charged, they migrate to the positive terminal, that is the anode, and at the end of it all, we are going to have bromide ions being discharged. They're discharged by losing electrons to the anode, and hence forming a brown or red vapor of bromine. It is either red or blue. It's either red or brown vapor or liquid of bromine. So let's balance the equation also by putting here a 2 and here 2 bromide ions being discharged to give us bromine liquid at the anode. But remember, I told you it's not proper to write a negative in our equation, so what we have to do is to remove the negative sign by transferring the 2 electrons to the other side of the equation. So we have 2 bromide ions that are being discharged to give us bromide liquid or bromine liquid plus the 2 electrons lost. Now those are the half equations that occur at both electrons. We are supposed to write now the full equation. Supposed to write the full equation of the reaction that took place. Writing the full equation, you should add up this first equation, then this second equation. Good enough. Number of electrons in the second equation is equal to the number of electrons in the first equation. Therefore, we just add up the equations. So we have lead 2 plus, then plus 2 electrons, this is aqueous, then plus the 2 bromide ions, aqueous, will give us bromine liquid, then plus lead a solid, then plus 2 electrons. What we see that in that reaction or in that equation, we have 2 electrons common at both sides, so we cross them out, and hence we write the final equation. Our final equation will be lead 2 ions, then plus, which is aqueous, 2 bromide ions, aqueous, giving us bromine liquid, then plus lead solid. So having looked at the first factor,